Hey guys, in this video we are going to cover ray marching in Houdini and create a fractal scene similar to this. So first off, let's go ahead and give some credit where credit is due. And if we jump over to Shader Toy, you'll find this individual that created this ray marching shader for this particular fractal. So check this out. This is also a great resource and great site for ray marching and shaders. So definitely check that out. Also, this individual here created ray marching for Blender with geometry nodes. Now, we don't have geometry nodes per se. We do have BOPs, but some of those nodes don't really exist in Houdini. So the workflow that we're going to cover is how to use Vex to create something similar to this using those same principles. So let's go ahead and dive right into Houdini and talk about the scene. So this scene, as you can see, there's not a lot to it to create this really dynamic fractal. And I'm going to give you this file, and you can find this file in the description for this video. So check that out and download it. You can go ahead and use it right away. First things first, what is ray marching? So ray marching, if we turn that off, you can see what ray marching is doing is this is actually a grid that has been rayed in space to where this fractal would exist. So if we back up a little bit, we can see that we actually start just with a grid. This next node, what this does, if we go to our UV mode, we can come here and we'll see, we turn that on, that this essentially just projects some UVs onto the node so that you can take it into Substance Painter or Mari or whatever and do some texturing, set up some actual shaders for it. This next node, what this does. So for this to work, we need this camera and this grid to be associated together. And right now they aren't. And so what ray marching needs to have is for this grid to be in front of this camera, and this camera is going to ray this grid to the fractal that exists mathematically, so to speak, in space. Let's go ahead and step through this a little bit. And I'm going to disable this offset for a minute just so that you can see. Here we have essentially just copied this information. So this translate information, if you right click and go to copy parameter, dive into your GeoNode, come here and you can right click and paste relative reference. Do that for the translate and the rotate, and it just brings that same data for the translate and rotate over to the grid. So now if we look at it, we can see that no matter how this camera is rotated, that grid is going to be right there in front of it. Now we want a little bit of offset. We don't want this grid right on top of the camera. We want to give it a little bit of space so that we can fit that into the frame of the camera. That's what this offset does. So if we turn that on, you can see it just offsets things a little bit in Z. So now if we come back, we can see we have something more like that. And if we look through this camera, we can see this grid has been scaled for this distance to fit right inside that camera. The next thing is this grid, the normals are actually facing this way. So we want the normals to face the camera. So this just reverses that so that we're getting good normals facing the camera. The next node we have here is a null where we've just done the same thing. We've imported some of that camera data and then piped that into the solver. So this is what a SOP solver does, is it does a simulation so we can play through and it'll simulate what's happening inside. So let's go ahead and dive inside. This code right here, this is the Vex, and as you can see, there's not much to it. There are some comments in here so you can see, like what this function is and what it's doing. Some of these comments, fold space, square radius, scaling. So this is essentially, these commented outlines are telling you what this code is doing. So there's some comments in here, read through the code. If you have any questions, post it in the discussion. I'll try to come back and look at this, maybe answer some questions and so forth. But yeah, anyway, let's go ahead and dive into using this. So that's pretty much it. So we just got some Vex. It's a point wrangle and it's inside a SOP solver. So I'm going to turn on this solver. We're going to come to our camera, and then with this eyeball turned on for that SOP solver, we're going to click the play button, and you can see that this is ring the grid to the fractal. And the cool thing about this is this fractal exists in 3D, so you can actually get that back to the camera and lock the camera. So if you want to rotate the camera, make sure you're looking through it and click this little lock button. And now you can tumble around and kind of get some different angles. And so now if we rewind and play, we can see now we're getting a different angle. So you can tumbled this camera around quite a bit and get some different angles and things like that on this fractal. So anyway, that's pretty much it. The last node that we have here is just a node to save out a geometry. And so this $hip, that just means wherever you have this Houdini file on your computer, it's going to make a geo folder right there where that Houdini file is, and then it's going to save the geometry into that folder. So yeah, this is the file. I will put this on a Google Drive and then put the link for that in the description, so you can jump in right away, use this, save it out, take it to Substance Painter, put some textures on it, and render. Anyway, I hope this has been helpful, and this is actually a really exciting area that we can play with in Houdini is ray marching. It opens up a ton of different fractals and a ton of different things that we can do with it. So explore, play. If you come up with something really cool, send it my way, because this is just one fractal. There's a lot more that we can do with it. If you guys have found that this has been helpful, consider subscribing to the channel and we'll make more videos. Thank you so much.